Alrighty. Let's see how we do. Hi, Chris from Airwindows, and I'm going to set up some of my various stuff. And as before, I'm woefully unprepared for this stream, but it's for some good reasons. I'll fill you in on those too. Let's see now. Let's make a chat window. This is actually a very inefficient way of putting chat on a stream, but it's all good because at least it works. And I've got some maintenance and stuff to do. I need to set up the camera for my soldering. I need to plug in the soldering station and get together some various stuff that'll involve me taking off my mic and running around doing it. But I got the camera ready. So what we're going to do is set things up. And one thing I have got is my little lavalier mic. And a camera I can use, so it becomes a question of, can I move this thing over and re-plug it in? Here's me unplugging it. It should still be, yep, it does seem to be still running. Tell you what. Let's watch it. Oh, and you might see I'm wearing a t-shirt. I have a story to tell about this, which I will do once I've sorted some of this other stuff out. Firstly, let me get this power cable over. Whoop. Yeah, all talk well doing things. I've been quite busy and distracted on a number of fronts. One of them is I might very well have another shelf in here before long and a new thing underneath it, because I have been asked, hey Jess, I have been asked for another plugin task. Specifically, people are wanting another classic drum and bass hardware implement to be implemented yeah, don't mind me shuffling cables here. This mic cable needs to be over here for a bit, and this needs to scooch over here, at which point the mic cable can stretch down here. And I'm also going to shut off this camera so that I can switch lenses, because this is not the lens I'm going to want for what I'm going to be doing. Here's our cheesy little stand. The cheesy little stand in question is actually a stand for laser surveying tools. I got it because it has these I got these stands not because they're great, because they're lightweight, convenient, and they have these quick releases on them. Meaning that I can have it set up and have another one set up in a different location and just sort of release the quick release and zoom the camera over to where it needs to be. At least that is the hope. And let me see. So the next thing here is to go and find the lens. It won't be that hard to do, but bear with me for a second. Which of these lenses is the macro lens? Are you the macro lens? Why, yes, you are. Okay, bear with me for a second. Hey, David. Hey, if we stick around long enough, we might actually make an electronic circuit today. That is my hope. Oh, dear me. Have I just pressed something on the back to change this camera and make it do something? I sure hope not. That would be most inconvenient. Okay, let's see what we got. I think this lens can sit back over here. Yep, still planning that, although they're going to be somewhat minimalistic. I would not expect like a lovely, elaborate kit that one would use. It's not going to be like that at all. So here we go. So what are we looking at? We're looking at a nice big close-up of what I will be soldering. And I'm going to have to glance across the room to see where it's being framed. But all in all, that ought to do it for the purpose of what I'm talking about. You'll forgive me moving the camera around a whole bunch and stuff. That's going to just be what you get. Whether you forgive me or not, it's going to happen. So, oh well. Let's see now. And I'm going to need more light, but I got that taken care of because I've got back over to the other camera. I made this. This is a newer light stand with a ring light. And this is a thing which mounts a tom-tom onto a cymbal stand. So I've got it clamped onto the light stand and electrical tape some of this stuff together. And then this is a cowbell. And there is a soldering iron electrical taped onto the cowbell. So this is now my DIY soldering station for video purposes. And if I set it right here, which you can't see, and also hook up the power for the video camera. If this ends up being enough of a thing, it might end up sitting around being set up like this all the time. Hard to say. But for now, let's plug in the power cable to the camera again. That worked. And plug in the soldering station and the light. Here, have a SD card for reference. So the next thing I got to do, boy, I don't have much water, but I have to pour some of it on this little sponge because it's part of the soldering station. If I wind up in bad enough shape, I'll have to go and get myself more water. And let's see, what other things do I need? Well, for one, it might be a good idea to go and get a good long cable of some kind, because I've got this. That's a guitar amplifier with a Fender Rhodes plugged into it. But I might also be able to connect circuitry into it so that you can hear stuff even if it's hearing it from kind of across the room. That's just maybe. I tell you about how I was not prepared. Let's start with a little bit of planning and also filling you in on what's going on out there in Airwindows world or likewise. And I can tell you some of the stuff that I'm working on that has got me busy enough that it was difficult to set this up, and so I kind of didn't. And we can figure out what we're going to do today. To the extent that we can do anything today, which we can try. So, one of the things I can tell you about is, like what I already said, I'm wearing this t-shirt. I'm stepping on my mic cable. I'm wearing this t-shirt. I don't know if you ever heard about this before. This is where I got my API preamplifier. It was a store in Boston called Mercenary Audio. And the reason you won't have heard about it is it was run by this guy, Fletcher, who is a very cool dude and well-respected, suffers fools very poorly. And a tiny little bit before I got the preamplifier from this place, he ended up selling the business. And he sold the business in order to like he was in a divorce or something like that. He had a reason for doing so. Unfortunately, once he sold the business, he sold it to people who were maybe not super great, and the store became terrible. But back in the day, it was an amazing place to get fancy stuff and where you could ask the questions like people ask me very often, which is like, oh, what kind of preamplifier should I have? What this, what that? And the guy who had run that store through its heyday, when it was a really big deal and a lot of fancy musicians and engineers knew and loved this place. Oh, by the way, it's you saw that the label says, this is not a problem, while the other logo is, we're not happy till you're not happy. It's a funny place. Looks kind of like a biker shirt. Well, Fletcher is the guy that runs the place, or did in its heyday. Fletcher has bought the trademarks and stuff back. He'd been spending this entire time running a bar in like New York somewhere called Plan B. Well, this is apparently Plan A, and Mercenary Audio is coming back. So I am wearing the shirt sort of in honor of that. Another thing that I'm doing is I've been asked to do another kind of digital filter. That being variations on the EMU Z-plane filters. And the interesting thing about this is Z-plane filters are a big deal. There's a lot of that going around. Rossum, who invented them, has a Eurorack module that does these E-plane filters. And people get very excited about, like, oh, all of the different filter types and the very elaborate, insane things that they can do. Well, it turns out these filters are pretty darn key for certain music genres. Specifically, drum and bass, off of EMU samplers using the Z-plane filters is a big deal, but it's not quite as you would expect. Thing is, the stuff that's been using these filters has typically not used the fancy ones. There's lots of fancy ones. You can get all these interesting, very peaky, like format filtering things and stuff, and that's neat. But it's apparently not the heart of what makes these useful in a genre like drum and bass. What people were doing was using just the simplest forms of low-pass and high-pass filters and reprocessing stuff through them a lot. And when they asked, like they went and asked Andy from Cytomic to model a version of these filters, he refused. And the reason is, A, it's not an analog filter, so he's not interested. And B, they were like, well, it's bad. What you like is bad. Therefore, I'm not going to help. And the folks who were interested in what they were able to do were pretty capable of demonstrating what they were on about. But nobody seemed to have ears to hear what they were doing. And I read through this thread just recently, and I went, oh, hey, I hear what they're talking about. They're not getting these techies. They're not getting these, like, almost like Fletcher from Mercenary. He did a sort of art sculpture at a NAMM once where he was representing Mercenary or something like that. And he had a sculpture and he called it shite on a stick. Maybe not the word shite. And he had taken a large spike and impaled a Mackie 8 bus and an ADAT on it and displayed it as a work of art. And so folks who are of that opinion are not capable of helping the D&B folks get the sounds they want because they have contempt for the very concept. And I don't have to fall into that category, so I am capable of helping folks like that get what they're looking for. And that's what I was doing all yesterday, was coding a low-pass filter that was not the same as, say, an EMU low-pass filter or a EMU Z-plane low-pass filter. But some of the clues that were given in all this discussion of what was going on with it, and people talking down these filters because they were like, that's stupid, it's nothing but a biquad. Oh, a biquad, a digital biquad, is it? I can do those. It's a biquad form 1, and it does this and that and the other thing and so on and so forth, which just makes it bad, so you shouldn't want one, so go away. And it seemed kind of rude, like somebody comes around going like, I would like this Stradivarius, you don't want that, it's old. So the thing is, that distracted me quite a lot. And I am in the process of dealing with the requirements of what that's going to mean. So today what I'm up to is we're going to solder something together and make noises with it. And I'm thinking probably what I'm going to have to do is solder stuff together just in a circuit board and power it with a 9-volt battery because I don't have a power supply yet. And wire up some kind of way to run it to the guitar amp because I don't have an output yet. And I don't have ways of patching through to a direct feed yet. I don't have anything yet. Like if you wanted me to go and do modular synthesizer music, I'd be much closer. But as far as the DIY thing, much like last week, I don't have anything yet. But that's what we're doing, is we're going to start. And I was thinking there's a couple of possibilities. People tend to not talk to me when streaming, so that is kind of one of the reasons I'm thinking about doing something along the lines of a Minecraft stream where it's just pre-recorded and then I just post it. And I'll kind of talk off the top of my head about what's going on in Airwindows world while I do that. But for now, I do actually have a question. It's just a question that I might be able to skip forward to the answer. What do you want to see first? What's a good first? I've got these reference sheets that are also not done. And these pages printed out which show you what the parts of the chip do. And the idea is, and as you can see, I've started. I thought I was going to have more time. The idea is what you do is you look over this, and I'm going to need my reading glasses just to even be able to see it. Hey, Jason. Yeah, the generosity is going to be a bit skimpy today because I'm not going to be able to produce anything useful today. And I'm going to stop after I spend 2 hours banging away at this because otherwise I just straight up burn out trying to keep up. The idea with this stuff is you should be able to look up what something like this does. On the page, see there's a terminal diagram. It's in very small print. And it says things like Q2 drain, Q2 gates, Q1 drain. Because this is a CMOS dual complementary pair plus inverter. I don't remember exactly why I even have this, other than it's something that it can do. And this is not going to be the one that we're going to do something with, because I'm damned if I know even what it does. But I do have the instructions for what it's supposed to do. And if I can figure it, like we've got this little reference diagram of what this means. I might be able to see it easier if I put it on the other camera, which has a macro lens on it. But yeah. 4011, this is a CMOS NAND gate. It's another 14 pin. I've got a reference chart saying which ones are 14 pin and which ones are 16 pin. And I've got perf board picked out for both of those widths. With this one, I have a slightly more useful functional diagram. Although, well, slightly more useful is going some. Basically, I have to grind through some of this paperwork to make sense of this stuff, and 4011 is not a great one to start with. So here's an interesting one. This is the one that I built into a circuit kind of like this, but not this. I built a flip-flop into being an octave divider using nothing but wires and power supply. Hey, Ricky, Joshua. Here is a logic diagram for what the 413 does. And this is a much better reference to what you would do to make the thing work. You got Q1, inverted Q1, those are outputs. You've got clock 1, which is a clock input, and channel 1 reset, and D1, which is data input, and channel 1 set. And you wire these together in the right way, and they will make an octave divider or 2 octave dividers for you. Again, this is one of those that I've got because I was able to get them, but it's maybe not for today. Yep. Yep, Jess, quite agree. The thing with that is that he doesn't have to do a limited digital algorithm for running in very large scale integration. At least back in the day, they called it very large scale integration. So there's really no reason that he would do that particular one. But somebody should, so I have that in plan. Here's a 4015. It is a dual 4-stage static shift register. You could probably combine 2 of these chips in order to make it into a 16-step trigger sequencer. I don't know how to do that off the top of my head, but I think that's something that happens. Specifically, I think this is what's inside my Turing machine modules. And you could spend like $70 getting a really nice kit for stuff like that, or $100 buying them directly, and they have a lot of different parts. But the actual chip is 25 cents. And it seems to me that it might be worthwhile building trigger sequencers that you could build for $1 or $2 and just having masses of those. But we're not going to build that today either. CO417 is a CMOS counter divider. What that means is it is multiple outputs. They call it 5-stage and 4-stage Johnson counters. Funny thing, I'm named Johnson. With 10 and 8 decoded outputs respectively. So this is the one with the 10 outputs. And what this device does is when you run one of these and keep putting inputs into one of the pins, the pin you want is clock, then the output voltage is going to step to one after another of these outputs. So this is a trigger sequencer that lets you put voltage to a bunch of different outputs, each of which could have a potentiometer or a trim pot or something on it, meaning this becomes a voltage sequencer, and you can do 10 steps of different voltages, because when you run it, the inputs step through the various voltages, and the outputs are always like voltage on this pin and not on any of the others. You run them through a diode so that the voltage can only flow one way. And then you take the output of that and you run it through a bunch of different knobs, basically. They're tiny knobs, like what I'm doing with these trim pots here. You can glue one of these things on so that you can turn it without having to spend $1 for each knob. And then you can have a whole bunch of these guys. And the outputs of the sequencer can all go to specific levels. And you sum them into some kind of summing amplifier, which is probably going to be an op amp. And that insulates it from outside circuitry stuff. And then you have a CV sequencer. Whatever you dial in on the knobs, it's going to keep doing that sequence over and over again. And that means you can make melodies and things out of that. And again, the chip is like 25 cents. And the individual pots, as long as you're not getting real knobs and stuff, and faceplates and all that fanciness, the individual pots are also relatively inexpensive. As long as they're like trim pots and stuff. Just bargain barrel stuff. Hey, Eddie. And that is a 417B. This is more likely to be an early project, but I ain't doing this one today either because there's no chance I'm going to make anything happen. One of my problems here is I have to draw out on all these individual pieces of paper the rough diagram of what happens in there and where so that I can start soldering them together on the perf board and making something relevant happen. This is all more improvisational than the usual run of doing this kind of thing, but I do have to have a head start, and that's why for the thing that I'm going to be doing, it's not going to be the 4024. This is a ripple carry binary counter divider, meaning that this is like the dope for, do I have one over here? Yes, I do. The dope for A160-2 clock divider, or at least one of the behaviors of the clock divider. Because what you do is you feed a series of pulses into one of the inputs on this, and then one of the outputs is every other switch, and then one of the outputs is every other below that. Basically, each one is divided by 2, divided by 4, divided by 8, divided by 16, and so on. That's what a ripple carry binary counter divider will do. So this is for counting slower increments of time, or for running some really high frequency sound through and making a crude sawtooth wave out of it, or there's various stuff you can do. 4046. This is going to be very cool as far as making weird sounds, but I'm not ready to do anything with it today. In fact, I've never actually worked with one of these. I just have some to play with. It's a micropower phase locked loop. So this is an oscillator that chases other oscillators. And you can either make it lock on to the other oscillator very nicely, or you can screw it up in order to make weird, horrible sounds, and that's probably what I'm going to be doing with it. This I've already started. My stuff that I do this way is going to look like this. I don't have a small plug version of the chord slide rule thingy. That would require a GUI, remember? Can't do it. Can't do that. Although I could probably code a Godot application that was cross-platform, basically like a game that did something along those lines, but that's for another thing. So 449 is a hex inverting buffer and converter, and in one of these streams, probably pretty soon, because this one I know, like you can see what it says as far as the instructions go. You've got this thing where it's got a positive pulse, and then there's a circuit diagram, and then there's a negative pulse. It's a 16-pin chip. I've also written some rough circuit diagram things here. This is NOT, this is an AND gate, this is an OR gate. And that means what this chip does is this. It is 6 NOT gates. And since I picked out a UB, it's a 4049 UB or 4049 UBE, that doesn't actually stand for tube or UB. But this is what this thing is good at. Although it is also good at blowing up if you use all of these for nonlinear stuff. Since it is a NOT gate, these are inverters, but since it's a CMOS circuit, these are electrical circuits that you power through the plus, voltage plus, and ground goes here in the minus. And then if they get logic values, the output is going to be the opposite of the logic value. But if you put a resistor across the output and the input, that means if the voltage is high, then the input is high, meaning that it's pulling it back to being low, and back and forth. So what you get is a way of resisting the tendency for the thing to only want to do logic values. You end up biasing it into operation as an amplifier. And when you bias it into operation as an amplifier with a low resistance, that is also negative feedback, meaning it will tend to cut down the volume of the output to, essentially, if it's a short circuit, then it's unity gain, and it's also compelled to burn a certain amount of electricity doing nothing. But then if you have larger resistance than a dead short, you start getting amplification. And if you have a very high resistance, like say 10 megs or something, resistance is in the mega ohms, what you will get is a inverting amplifier with gain and distortion. That's what the neat thing that the 4049 can do, is it's an incredibly primitive and basic building block that you can use for distortion boxes, EQs, any number of things. And everything that it does is going to be dirtier and more fuzzy than you get out of, say, an op amp. Because op amps are very clean. Using the 4049 chip as amplifiers is very dirty. Using the 4049 chip as an amplifier is one of the ways that you can make a triangle wave into a sine wave, by basically distorting and clipping the top of the triangle wave so that it rounds off. That's how soft the distortion of the 4049 chip is. And again, one of the challenges there is that since it's not designed to do that, if you do that with one of its inverters, it's going to burn extra energy because it's not able to sit at either a high or low output gain. And if you do that with multiple of its inverters, it starts to suck a bunch of power and generate a lot of heat. And they can burn up through doing that. Like, you probably don't want to use all of the gain stages at once, although I have done that. I've done that and had the chip sort of floating. Like, that's what the poster frame for this live stream is, a picture of a circuit that I built with some of these 4049 chips wired up to do various things. And I have taken these and run all of the gain stages in parallel to try to get more power out of it, which was a silly thing to do, but I did. Anyways, to continue to skip onwards to the one that we'll hopefully do something with, 4051. This is, let's see, what is this? A 3-bit 8-position switch. This is really going to require me making a label for it. So what you get is, and I've got a 451 and a 452. This is kind of like some of the other switches. Like over here, there's a 466 CMOS quad bilateral switch. The secret here is that there's stuff I'm going to be able to do regarding like a switch like that, where you set up a bunch of oscillators that are just little square wave oscillators. It is possible to make a kind of cymbal sound by taking a set of little oscillators. I've got a couple of Blue Lantern devices that do this. And they're just all little square waves. But what you do is you run a couple of them into a XOR gate. Exclusive OR means the output is high only if one or the other of the inputs is high, but not both and not neither. And it acts kind of like some kind of crazy ring modulator. You run 2 square waves into it, and the output that you get doesn't actually sound like either of the square waves. It's a kind of weird, nasty rasp. And if you run another square wave into that and another XOR gate, you wind up with a cymbal-like sound. You wind up with a sound that's like white noise, but it's not, because it's a little bit more weird and primitive than that. And the Blue Lantern Mini Shimmery plugins that I've used for hi-hats and snares a long time use that technique. They use exactly that technique, but you could also use the 4051 or the 4052. And like, since the 4052 is a dual 2-bit 4-position switch, that means you can hook 4 different oscillators to the inputs of this switch, one of the switches, because you get 2, and then 2 more oscillators to the bits that control what the switch is connected to. And you're going to end up with 6 oscillators making a really complicated output, because you've got 2 bits that are both flipping around randomly, or not randomly, they're oscillating, and they're connecting to any of 4 different other oscillators, but only one at a time. And that's going to act very similarly to the XOR thing. So yeah, speak of the devil, 4070. 4070 is a quad exclusive OR and exclusive NOR gate. Here is the picture of how it works. I'm not sure how well my focus is doing, but whatever. Yeah, there it is. See, that's the picture of what the OR gate is. This is written in terms of A's and B's and things like that. But what I'm going to be doing is tracking down all the details of what connects to where and drawing this up so that it shows on the face of it, like this pin connects to this, which connects to this, and this is the shape of this little OR gate in here. So if you wanted to make it run, what you do is you run a wire input into here, and then inside it does this and that, and you take the output out of there, and so on and so forth. These are the things I got to do in order to get fully cranking with this stuff. And we're walking through these just because, on the one hand, I want you to know what I'm up to as far as plans for these Wednesday streams. And 2, like I said, I'm not remotely prepared, so this is killing time to some extent. And then when I'm finished, I have to resume coding hundreds of Mac VST plugins for signed Apple Silicon stuff, which is going to be another weeks of work, and also the new plugins which are coming out. So these streams are marking time until I start to get this ball rolling. I've had 10 years to get the plugin making rolling. This, I have a lot of the raw materials ready, and we will see where it goes. CO4081B is a AND gate, and the 4081B specifically is a quad 2-input AND gate. So what this basically is a set of, see, the logic diagram seems to have a lot of knots in here. This is what the circuit actually looks like. As far as running audio through it, I'm not sure what that's going to be about, but it seems to have a pair of knots for the inputs, and then another one of my pages had better information as far as what that means. That looks like a NOR. And then a couple of inverters for buffering, I suppose. So essentially what this does is make a kind of switch where you could have a trigger input going into something, but the trigger only produces an output when the other input also has something turned on. And I'm not really sure how that'll work with weird voltages. So that's one of the things that we'll be experimenting with, because part of the reason for doing this, part of the reason for doing all this kind of stuff, is that unlike programming in a computer, we can do things like this and then starve the voltage to the chip and see what it does. We can do stuff where the inputs to the logic gates are not getting as much voltage as they're supposed to, and so they get into this weird nonlinear, ill-defined behavior. And that's very likely, like there's a number of things that happen. This AND gate, you can literally see what this is. Definity? I can answer that. In fact, not only that, here, let me drag the microphone over to this other. This is not going to be a very good image, but I bet I can at least show it. Or not. So you see where there's lines and then sort of little T's, which there's a little gap between that and other lines. That represents field effect transistors. And it makes this logic diagram here. Like you can see, those are diodes. And the squiggly, angly thing is a resistor. And the inputs kind of go like this, where you've got, a line going to two of these little 3-position things with the T's and the lines going off of them. And then dots where the lines cross, that means that they connect there. So this entire gate, this entire AND gate, is being made by field effect transistors, which are the same kind of thing that you have in the 4049 chip. And the 4049 chip, remember, is the thing where if you wire the output to the input, you get a tube-like amplifier. You were driving it in a nonlinear range that is neither logic 1 nor logic 0. These are exactly the same thing. All of these little elements are going to act like tube sound fuzz. The question is, can you bias it so that it's going to pass analog audio all the way through? Or is this just not hooked up in such a way that that would work? Like by contrast, I'm going to try to dig out the 4049 and see if it had a wiring diagram inside it. Here's the 4070, 4052. Here's the 4049. Yeah, here, check this out. Not that you can see it very easily, but I'll try to move it to where you can see it. See this? This is the tube sound fuzz. The reason it works is it's unbuffered. And you got these, the diodes, which is the triangle and the line. The diodes are stopping it from killing the FETs inside there. And the whole thing works with these two field effect transistors. And that's this stuff here on either side of the out that you see. I know it's kind of blurry. I don't have a good camera set up. This is as good as I can do today. So you recognize that? That's exactly the same thing that you saw in the other circuit. It's just bigger. There's more to it because it is a chip. And as such, this the 449 has 6 of these hooked up. And this point where it says in and out is where the pin is that you connect to. So if you're shorting it with a resistor, you're connecting a resistor between the in dot and the out dot. And when you do that, it is biasing it into being halfway engaged. And what it's going to do, if you do that, as long as there's enough resistance there to make it do that, it's going to start amplifying signals, because that's what a field effect transistor will do, in a kind of noisy and a kind of soft-edged blurry way. But it's very quick. Like it works on computer frequencies. So the rise time and fall time, although for the 4059 it's not all that great. It's like somewhat limited. But that said, you saw this design, this arrangement of like the line and then the three little T's. That represents a junction. The line represents whether there's voltage at this junction or not, because you can see that it doesn't connect to either one. That also means that the input impedance of this, it's a FET, it's a field effect transistor. Literally, it's just floating. It's not actually connected. But when there's electrical power in the circuit, depending upon whether it's a positive or a negative voltage, or perhaps it's depending upon whether it is a 0 or a positive voltage, it's going to take one or other of these connections and it makes these little T's short together. The little T's become a switch and they engage harder and harder until you're basically shorting out to whatever is up here, which is VCC, voltage, or shorting out if it's the other one that's engaging VSS. That's a ground symbol right there. And we're doing that at audio rates. So the electrical energy that's not actually connecting to anything, because it's a field effect transistor, it's just it's affecting electricity in the field around the circuit, is alternately shorting out one or the other of these. That's why it says P and N. Transistors come in two forms, PNP and NPN. And that is having to do with the way that the junctions are constructed. The exact details I don't have on the tip of my tongue at the moment. But essentially what it means is either it's going to turn into a short, turn into a connection, if it has no voltage on it, and having voltage on it makes the connection go away, or it's going to turn into a connection when there is voltage on the other side here, and then when no voltage is happening, the connection goes away. And this is the same thing for transistors, because a field effect transistor is also a kind of transistor. This happens to be a transistor where just this sort of floating energy of the voltage sitting here is what makes it do a thing. And when you short circuit it, what you get is it's holding it at a medium voltage where both of them are partly on. And because it's a inverting thing, if we didn't get exactly the right voltage to have it be held partly on, it will gravitate to whatever voltage it needs in order to do sort of the intermediate thing as much as possible. So let's see, let's skip back over to the rest of my thing. So this is turning into a lecture on what these things are, but I feel that's valuable too. We'll go back to this as needed, but in my poor, scattered, beleaguered brain, we will do as much as we can with what we've got today. And the rise and fall time do exist, but they're in the nanoseconds. One of the things that you do when using one of these chips, which I might drag out and try to do something with today, is use a capacitor to store up energy in such a way that you could make an envelope or something out of it. Again, let's continue skipping forwards because we're almost to the one which we can actually do something with today. CD14538. That is a thing called a dual precision monostable multivibrator. And it says it does Stable, retriggerable, resettable, one-shot operation for any fixed voltage timing application. You know what this is? This is just a trigger manipulator. I've got a dope for dual trigger delay, which is literally this. The dope for A162 TDEL has two of these guys. It's basically this chip. It's roughly $70 because dope for modules are affordable. But it's $70 for wires and circuit boards and knobs and jacks and things. But if you needed to build your own synthesizer and you needed that to be done, again, this chip is like 25 cents, 30 cents kind of thing. Yep, PNP and NPN are types of silicon. Yep, exactly right. I know there are going to be people in here who are up to speed with this kind of stuff, and I'm also going to talk it through for those who are not, and we'll just see what we get. These are going to get more lively as I start becoming prepared to actually build things, and as the list of things that I've built starts to accumulate. Until then, yeah, we're going to do the best we can with what we got. So, what's a monostable multivibrator? It's this. If you run a trigger into the input, and you get to pick, actually, you get to pick a bunch of things. You can run a trigger or a series of triggers into this thing. And when you run the first trigger, the output also triggers, but you can make it delay. So it slows triggers. You can make it so that, okay, there's a swing or a groove. You send every other trigger to one of these, then you can put a swing function. Or you could take your triggers that are going to, say, a snare or a sampled snare, and you want to have your snare get a human feel and have a good backbeat rather than a very machine-like backbeat. Throw one of these on here. And it is, you can delay how fast that input trigger produces the output trigger. And what I mean is you can delay it in seconds if you wanted to. You could just make it wait forever. You can also determine how long the trigger stays open, which means you could have a very quick trigger coming off of some kind of timing sequence. And if you wanted a chord or a bass note or something like that, it'd be like boop, boop. You'd use one of those and you'd trigger it so that it would turn on immediately. And then you would have it with a capacitor in there so that it slowed down turning off. Also, it doesn't re-trigger until it's turned off again. Also, you can tell it to trigger on the end of a trigger coming in, not just the beginning. So under normal operation, it would be the leading edge of the trigger, but then you can also tell it to be on the trailing edge of the trigger, which I probably would not do. But these are all things you can do with this chip. It's a nifty, complicated chip. It's a high voltage type, meaning it can take 20 volts. Hey, Joko Sagovan. This is a weird stream, so we got about an hour or so, and it's a blathering about chips stream today, because as with last week, I'm not really prepared. But I'm showing you what I've got so far and what I'm going to have to continue to get together in order to do this properly. Here's pay dirt. This is a CD40106. Using this, we can probably make an oscillator today. There's just a hair less than an hour to the stream, and grappling with this kind of new stuff with nothing prepared is exhausting enough that I'm probably not going to go beyond 2 hours. But we can probably make this do a thing. So I don't have my layout. I've got this sort of instruction manual here. It says channel A input, inverted output, B, C, D, E, and F. meaning that we've got 6 inverters. Remember how there was the switch for 4 on one side and 1 on the other side? See, this is where that could come in handy, because although I'm not going to have that today, if you have one of these chips, you can make 6 different square wave oscillators out of it. And they could be like a swarm, or you can manipulate them in such a way that they're giving you triangle wave or sawtooth wave outputs. Because the way this works is much like any logic inverter thing. You're making a oscillator, and what that's doing is you've got the input being either 1 or 0 on or off, and the output being either 1 or 0 on or off. But I think the way that it works is that if you take the output directly, that gives you your square wave. But if you take the input, what you get is more along the lines of a triangle wave, because there's a capacitor there charging up and discharging. Yeah, I mean, as far as the parts, this is why I've been buying these things in quantity. This is very much where I'm going as far as, let's build these things together. Oh, if you don't have those, I'll mail you some. And when the end of this month comes, I'm going to make a record of exactly how much I cleared $2,000, if anything. And assuming that I do, and eventually I will, I'm going to write down exactly how much I literally got from Patreon. See, when it's over $2,000 on the website, I've committed to doing these whether I'm ready or not, as it happened earlier than I meant. But when I actually get paid, and that turns out to also be beyond the threshold, I set aside the amount of money that was beyond the threshold, and like essentially put it into a jar for the purpose of postage and stuff, and getting together this stuff which I can send to people, and that's the amount that I'll do. So if I was getting this started and it's like, okay, $5, and I didn't actually do anything that month, then I would carry it over to the next month, which maybe would be $10, and then I would have $15. And the idea is I would spend that $15 on sending stuff to people. That's the idea. As far as if you're talking about whether you could make a circuit on a wooden board, you could. Epoxy board is more interesting because you can get it with holes built into it. Then the final pages I've got here are like, this is a DAC 800 digital to analog converter. So all that is inside this guy, we've got a bunch of little transistors. You can see from the way that they're shaped, they're not field effect transistors. And they've got little resistors along them and current switches. And using this, the way that it's set up, and apparently there's a bias network. I'm not really quite sure how that works. But you can make differential output voltages of 20 volts with simple resistor loads. So the idea is that you can get a 8-bit audio waveform out of this by just feeding digital inputs into the bits. And there's any number of things we can do along those lines, like for instance making, for say, 8 little you could do 8 little oscillators. Yeah, one of the things I might be able to do today is literally a soldering tutorial. Here, let's turn the soldering iron on if it's not already. It's not already. With a bit of luck, that actually is something that you'll be able to see. That's the whole point of having the the macro camera there, as you should be able to see what I'm doing. This is a 15-watt audio power amplifier. I haven't actually used it for anything. I was thinking I might be able to use it for reverb tanks or something. And then we start getting into op amps. This is a special op amp. It's a kind of op amp where you can set it to have very low power draw and very low slew rate. So this is your special crunchy op amp with the limited slew rate, even more so than most op amps that are just that way for cheapness. It's also the kind of op amp that exists in EMG 81 guitar pickups. We got OPA 2132, which is a higher quality JFET input op amp. When they say JFET input, that means that it's one of those circuits where it's not actually connected through to resistances and things. It's just kind of floating. TLO 82 or indeed 81 dual JFET input op amp. These are incredibly common. I have large quantities of these guys. Useful things, or 70s. TLO 71 is also handy. And the last thing I have been making as far as these things, which I have to fill in, almost all of them I still have to fill in. The only one that I have done is an early version of the 4049, and that's not the one we're going to be doing something with today. But this is a chip that is a echo processor, and this is how you wire it up. If you do that, you've got a little echo box as just a chip and some wires coming off of it. We should be able to do fun things with this or things like it. Wiring stuff onto perf board. Yep, exactly. Because believe me, there's some fun stuff you can get into. I was showing earlier on, God, I sound terrible. Sorry about that, blow your ears up. I was showing the 4046 phase-locked loop. Well, guy in Australia from nonlinear circuits likes doing a lot of weird chaotic modules, chaotic voltage generators, and you can do those with just op amps. And he has made phase-locked loops into the delay effects, into more phase-locked loops, into the delay effects. Almost everything this guy makes generates such gloriously horrible noises that it's really quite entrancing. We will see whether we can wire up something like that too. For now, here's what I'm thinking. Yeah, I know, right? That's the idea. You can be spending hundreds of dollars on this stuff from DIY people who are building them into actual things. The box, the knobs and things are a pretty huge deal. So let's see, where are we going to start? Where's my 40106? There it is. So my chart is useless to me because I haven't filled it in yet, but here is some of what we're talking about. I think I may just sacrifice one of these and see what I get. So hang on. I gotta take off the mic for a second. Go get my shopping list of things. There's the mic. So I need the chips. Here they are. I'm going to need a 9-volt battery clip because I don't have a power supply yet. think everything else is where I can get it. So possibly not. Hang on, I'm just thinking. Let's grab these while we're at it. I'll just grab a couple of them. Little collection, because I'm going to chop these suckers up. And I want to do one of these so that I can power it. This goes back over to where I got it. And what do we have here? One thing we have is some grade filters. Let's grab one of those. That's a 200K trim pot. And capacitors. And let's see, what was the... Anybody remember how many pins this had? 14. So as you can see, I have prepared in advance some of these little guys. Maybe you can't see, but I'll move it until you can see. And let's see, while we're at it, oh yeah. So here is a tantalum capacitor, 6.8 microfarads. Here is a polystyrene capacitor. And gosh, hang on. And I think if I play my cards right, I can run a wire over. I'll put that in. And a wire so we can hear what we do. Alrighty. So let's see, 12, 16, 18, what the hell time is it? About 45 minutes. So let's see what our little environment looks like now. Well, I'll tell you one thing, I have to make it so that I can see the screen. Hang on. Hang on. Oh, and I don't even... all of that, and I wasn't even showing you what it was. Alrighty. Work in progress. I am so unprepared. There will be future days where I am more prepared than this. This is not one of those days. So you can probably hear I have got a live wire here. Not really working very well because, oh, hang on. A little more light just because. So let's see. You can't see a damn thing I'm doing right now, but I'm just juggling all of this stuff. You battery, go away. You wires, go away. Not going to need that. So here we have, this is going to be the output. By the way, this is how I solder these things together. Kind of like that. So that sucker is gonna, no, it's just the hot wire. This is where you'd plug into a guitar or something. And I've got perf board. I prepared this in advance. It is 14 pins, so you can see that it's kind of centered on one of the holes in there. This is what I'm going to be using. As you can also see, it has one of the edges from the end of the board. So this is kind of a sacrificial one. When I make ones for keeping, I'm probably going to want to use ones where both of the ends look like this. But I'm going to use this one for now. I've got this stuff. These are pin jacks. And I'll demonstrate some of what I have in mind for that. Here's the capacitor. You can kind of see it, only not. There's not much shown here. It is a tantalum capacitor. And that seems to say six something. 35K. It says the 35 volts tantalum capacitor and it's 6.8 microfarads. That's probably what it's, yeah, it probably says 6.8. And there's a tiny plus where it is rounded, meaning that this is the plus side. This is a capacitor that doesn't have a plus side because it's polystyrene. It works in either direction. The thing about the tantalum is that it'll explode if you do it wrong way with enough voltage on it. But this is a 4700J 50 volt. They're smaller capacitance, so they can be a higher voltage because you don't have to have as many windings or whatever it is that you use. And this is a trim pot, and it's going to be the thing that we use to make the thingy feed back, which is essentially what we're going to do to make this do a thing. Boy, am I scientific. That's the sort of thing that you're going to have to get used to, I think. I can still kind of sort of see chat. I don't know what you're talking about, Joku. This is 60 hertz here and it's 50 hertz in Europe. Yeah, there you go. So here, now ideally, what you also want to do is, hear what I'm tapping? That's a radiator. That also will serve as ground. What I will do is I'm going to kick off my slippers and my socks will touch the floor, and this will hopefully do at least a little something towards keeping me from generating a lot of voltage. I also can see one thing that I need to get. I was going to get a capacitor. Don't mind me getting rid of temporary stuff. Don't need that. Don't want that. That might be nice. Damn it, I know I have caps here somewhere. Where are they hiding? Okay, so I have caps to use for this and I'm not finding them. Again, not prepared. So we're going to cheat. I don't have the right caps, but I have the wrong ones. We're going to use the wrong ones. And I do at least have a slide pot that might be fun. Yes, trim pots over knob pots. There's my mic. Yeah, you can see why I'm going to have to stop at 1 o'clock regardless of whether we finished anything or not. Being this unprepared is exhausting. If I was trying to do this every day, I'd have a damn heart attack. But that will not be happening, so. That's the thing is, I needed one of these. But not just one of those, a specific kind that I can't find. I have hundreds of, I have like 1,000 of this type of capacitor, but a better one with longer wires, and it's a specific form, and I can't find it. I have thousands of these. I can't find them. I thought I had them in one of my jars of stuff, and I'm not finding it. So we're going to fake it. Not only that, I'm going to move this wire over here so that I can grab a bunch of rolls of hookup wire, because that's the remaining part of what we're doing. And I have a wire stripper that you can't really see, but it's good. I have a fingernail nipper, which you can't really see, but it's good. So I'm going to move the wire over here so that I can show some of these. This wire stripper is called a Trigomatic. It is the best, coolest, most convenient wire stripper you could possibly have. Closes in the wire like this, then closes in the insulation and goes. These are the bomb. You can still get them. You can get them used, and I think they even make some new ones. Trig-O-Matic it is. And then these are even easier. This is what I'm going to use to snip off the pieces of copper wire, and this is nothing but a toenail clipper. Get some kind of toenail clipper in your local dollar store or whatever. I'm glancing over at the I don't know what cycle is. So here's the deal. We're going to try to assemble a power supply so that we can act kind of like we're starting to do this properly, even though we're not. The whole concept of making this work is that we're gonna put connections in here like these are our jacks, and one of these is going to be our positive wire and one of these is going to be our negative wire, or we're going to have them closely related, and we're going to plug our positive wire into the little hole like here. And then when we have an actual synthesizer made, we can just run wires over to wherever they need to go. And it will kind of extend. We can make a sort of elaborate structure out of it. Thankfully, this seems to fit into these just fine, so we'll do that. So first thing, and I'm trying to figure out whether the soldering iron is all I want it to be, or whether maybe I've let it be hot for too long and it's developed this dark coating. Here's the tip of my soldering iron. It's supposed to be nice and silvery. That's why I'm holding it on this sponge, which has water in it, is that cleans it. And you can see how I've done that, and it made it be more shiny. There's also stuff that you can use, like stuff like this, that you can dip it into and it'll kind of try to clean it off. It's kind of nasty and makes nasty smoke though, so I'm going to tend to avoid it unless I have to use it. So here's the next thing I'm going to whip out, which is needle nose plier. I'm going to say that my ground and hot connections are going to be 3 pins wide. So I've just broken that off. Another thing you can do, which I've seen somebody do, and I might take on that, or I might not, is use these kinds of headers just full width and then label them each. I'm maybe not going to do that this time. And see here, I've broken one off where there's only 2 pins available, which is not good. And that also left one of these. You can't even see it, darn it. You can't easily see what this is, but the metal pin is kind of sticking out of the end of the plastic stuff. These are fairly difficult to nip off, so let's start fooling with the nail clippers and see whether we can clip off a piece of this way. You can see where the little slots are there. So I'm sandwiching it in here, and I'm going to go clunk. And that has left yet another area where you can kind of see through to the middle part there. Not easy. This is not all that easy. And then if you have a single piece remaining like this, I've got actually quite a lot of just these pins without any of the plastic. Like, you can nip away the rest of the plastic. The pin will come right out. And then you've got this. And this is just the metal pin. This will serve just as well as a jack, but it's kind of tiny and you can't even see it. And it's also going to be a little more difficult to solder to, so I'm not sure I'm enthusiastic about using these as they are. I'm going to drop that in a little hole in the arm of my chair here where I can drop like wasted parts. And let's continue to see what we do. Okay, so I've nipped yet another one of these pins off. But in exchange, I got one of these little guys, which is fairly self-contained, and I was shooting to have two of these. One of them is going to be a positive voltage, and one of them is going to be ground. Also, I'm gaping over half-old plugins do the input sign thing. I'm actually not sure what that means either. I can barely see chat. You're like 15 feet away from me. So, let's move onwards. I'm going to take this tool and straighten out the ends of the capacitor. Not only that, let's move this out of the way. I'm moving old things all over the place because I've only got this one to work with. And this is the first sight of melting stuff with the soldering iron. I am melting the solder off of it to try to smooth it out because I'm going to stick it through some of these holes in the board. One of the other things that I have not prepared for is to see exactly how far into this board I need to start having stuff, because we're going to have stuff like this. Yeah, like that. And it kind of needs to still fit onto the rack rail, so I'm going to stand up and bonk the ring light and reach over here and see how much space I've got. And for this particular capacitor, it looks very much like I can put it this close to the edge, because that's how wide the rack rail is. So you can fit things this close to the edge. That's kind of the point of being concerned with this. And you know, those wires are just not long enough. I'm too frustrated. I'm going to go and get the real capacitors, because my basement has all manner of stuff in it. And I know that I can find some of those and just grab them and bring them up. So I'm going to do that. I still think it's very possible that we can get a sound before we are done. Okay, I apparently have literally none of these separated out to where I can work with them. Now, you know what? This is one way you can get capacitors. Look at them there. See these guys? This is what we needed. This reel holds 600 of these guys. If you're buying these things in quantity, that's what it's going to look like. I'm going to sit that there for the moment. Also, if I send you guys stuff, it's probably going to be in little clipped off pieces of plastic like this. I'm not entirely sure how I'm going to manage that, but that's probably how that's going to work. Oh, making noises. Oops. Alrighty. We haven't dropped any frame, but it's continually complaining about the stream bitrate. Fine, whatever. Okay. So here we are. Here's our make soundizer. Here's our little microphone connected. And goodbye to this. And hello to this. And I'll show you why I wanted this. The value is different. It is a 270 microfarad rather than a 1000 microfarad. But it's not really that. My idea is that when we're making power supplies for these things, we can have every single module. And if you get these in large enough quantity, they can be very cheap. I have hundreds, thousands of them. So I can throw a few of those into care packages as well. But here's the deal. This one has longer wires. I can solder stuff to those wires. That's the whole point. So let's run these wires through here. There's a negative and a positive side. I'm going to have the positive side be closer to the gnarly edge here. And I'm going to stand up and put it against my my rack rails. I'm not sure whether maybe making the camera's auto switch might be useful, except for that camera that I normally use is kind of focused in a particular place where I make videos. So that wouldn't even really help me right now. So here's what we're going to do. We've got a couple of these little things, and maybe the idea of using just a limited number is not actually what we're going to want. I'm trying to decide whether to include more of this. However, I can say one thing, which is I am going to want to loop these over using the needle nose pliers and kind of make them into a shape. I'm going to go up one hole and over two. You can't see that because I only have a macro camera, sorry. So I looped it over through another one of the holes, and I've got the needle nose pliers, and I'm going to pull it through. And maybe squish it down a little bit. Now, that's held on pretty good, and it's coming out the other side. And do the same thing on the other side. I'm focusing this up towards the top of the thing in hopes of having lots of space for putting things on this little board. I don't honestly need to be doing this the way that I would be doing going forwards. It's just that I got into that jam, so. So now, both of these are connected through, and both of them stick out the other side. I keep trying to see what chat is saying. Oh, I'm so unprepared. So these are about this long. Maybe that produces the answer to the question I have in mind, which is, how should I go about doing this? To the extent that all of this is done with little pin jacks of one kind or another, you can kind of see what I'm shooting for. When I finish making this, however long of a pin jack I make goes through on this side, and then I weave the wire around the pins on the other side, which you'll see soon enough, and then I'll solder it, and you'll see soldering. And once I've done that, that'll be a solid little connection. You can run power to, and then run power from. It's like a little distribution section. So yeah. So about how many pins is each of these going to take? I am counting 1, 2, 3, 4, 5, and then it doesn't reach. Let's give it a shot. Here's another way of cutting these, is the needle nose pliers also has a nipper section. There's a 5 and another 5. The end of this has bare metal sticking out, but you know what? That's probably going to be fine. And it's a handy way of doing these 10 wide pin sockets. Just trimming the end of this one off a little bit. Kind of like this. The idea of having all this macro stuff, although it's incredibly cumbersome, is you should at least be able to see some of what's going on. That is the hope. By the way, I've also got this jack here. I'm not sure whether that's something that I'm going to include in things, but it doesn't really fit in the holes. That's the problem. So let's leave that off for the moment. And here is weave in this one, which you can't see, but I'll show it to you when I'm done. This through the pins. In fact, you know what? This might be a fine idea to just solder some of them and go from there. So it's being weaved through the pins like this. Where's my solder? I do have solder. I don't know where it went. That's kind of important. I'm going to need that right away. Dear God. Okay, it's over there. Getting up, going and getting the solder. And it's already 12:49. However, you would not believe how close we are to being able to make a noise. This is like all of my damn streams, which is hours upon hours of slowly grinding away at this mindless, tedious stuff, and then at the very end, things start happening really fast. This might be one of those times. So you can touch solder to the soldering iron, but the way to do it is touch maybe the damp part of the soldering iron to the thing that you're soldering. And as you can probably see, I was touching solder to another part of the wires where this wasn't. Because you got to melt it onto the actual wires, you don't drip it onto the thing that you're connecting. Instead, you're heating up the thing that you're connecting and then melting the solder against the thing that you're wiring. It's quite significant as far as soldering stuff. Now what you can't see is I'm bending it again and trying to loop it over these last two, which I believe is going to be successful. Tweezers can also be handy for stuff like this. Like I'm going to have it go on the left side of both of these things and then just scooch it over. Ah, something bad happened. The little pin fell off. This is the thing I was trying to connect to. I think what this means is I'm not going to have enough of these, and so we're going to leave that one off. And you can see where it fell off. It's not there anymore. Thing is, I didn't really need 5. I was just doing that because that was as long as the wire was. So what we're going to do now is solder the last one in and call it a day. Normally I use better glasses for this as well. I'm not sure if that's contributing to the debacle that unfolds. Now, nip off the extra wire, nip off the extra plastic. There we are. And this is as solid as anything too. We need to do that again. We need to do that again with another little group of 5, which is these. And one of the things I was thinking about this process, this is also why I have some fancy electrical tape, by which I mean incredibly cheap Amazon electrical tape, but it has nice colors. I found this stuff and I decided I was so happy with the colors that I was just going to base stuff on that. And I can color code some of these things. Specifically, I can put a little bit of red electrical tape next to the one that is the voltage plus and do that. And there's also, like for future reference, when you get a disk drive power supply or something like that, computer type stuff, they got wires coming off of them, and it's black wires and yellow wires and red wires. That color coding has a meaning. So you will be able to get voltages that are like reasonably 5 volts or reasonably 12 volts off of a power supply like that, and I intend to do that. So I'll probably reserve some of those colors, the red and the yellow, for which voltages you're using, because although the CMOS chips will take 12 volts, some of our computer chips will not. You hear that? It doesn't want to hold. It's poking up, so what I'm going to do is melt it, scrunch it down, and then hold it down with the needle nose pliers until the solder melts. The solder solidifies. Anti-melts, I should say. And now, this is what I call a kind of power supply. Bits of it look a little sketchy. I think I've heated it up so much that part of the plastic melted. And it's not as stably mounted as I'd really like, but all the same, first try. This becomes the power supply section. Let's get rid of this end piece. And that left another area where you can see the metal, meaning that that will fall out, except for that won't because it's already been soldered in place. Might be a good idea to do the soldering before trimming these things to size for future reference. And we've got this one left over, which I'm going to drop in my little hole for stray parts. Next thing we do is not take the battery clip and plug it in, because that would be too easy. We already know how to do that. Plug in the battery correctly, put a little piece of electrical tape to indicate which part is red and which part is black, then plug it into the relative place, and we'll have a power supply with a capacitor. But the next thing is to start getting some of the bits that actually do stuff. I'm going to have to use my piece of paper too. Here's one that's just sitting over here. CMOS chip. Now the reason I've decided that these are a given width is because they will fit the chip. And I'm looking at the reference, it says top view. See, this says top view. And there's a dot shown. And there's also going to be a dot on the chip. So what we're going to do is put the chip on with the dot, which is VDD, means power supply. That's going to be 14. So the dot goes here, and the top chip is the chip that is also closest to the positive. And if we put this chip into here, looks kind of tarnished and nasty, but maybe it'll work. This now fills the entire size of our perf board. But we might not want to have it that close to the power supply because we might need space on both sides of it to do things. But for now, I'm going to call this one close enough and put it there anyway. This is a sort of example of how close you can come to the top of the edge. And I'm kind of spreading all the pins underneath so that it doesn't fall off. This is definitely a little more tarnished. I guess we'll see whether it works or not. And I'm going to hunt down a bit of wire, namely this wire, red wire. This is the kind of wire that I have lots of. But I won't need much for this. Using my little nippers and little wire strippers and all that kind of stuff. I have such a tiny piece of wire here that I'm not sure it's going to conveniently work, but we'll see. So now we have a tiny wire. And what we're going to do is identify the correct pin that this goes out of. I could probably have done with stripping it a little bit more, but it's fine. I'm bending it around a little bit so that I can poke it through this hole in the perf board. And solder it to this pin. Let's see if this works. Again, I'm trying to do everything within sight of the macro camera. That will make things more useful in general, but it's damn hard to do, and I've never done this before. I'm used to soldering things, but not quite like this. I'm going to flatten it out a little bit. And let's see. Ooch it over like this, and oh no, that just made it go out of focus. Over to here. One of the risks I'm running is that if I'm holding electric charge in me, touching these can kill them. So that's a risk we're going to run. We're going to see. This is, after all, a really rough trial version. And that should have done it. I touched the wire, heated up the wire, touched the solder to the wire, not the actual pin, and then allowed it to flow onto the pin, which also got heated up from being touched to the wire. And there we have a wire that's connected to the voltage in pin of the chip. And I can kind of bend this around with the needle nose pliers. You can't see it, but I'll show it to you when I'm done. Poke it into the jack and insert. There. Now we have a IC where the hot is wired to the chip and then is also plugged into one of these jack inputs, which is wired to the capacitor and will be wired to the battery clip and or the outboard power if I ended up moving this to outboard power. Next, black wire. Black wire for ground, because that's the color that's on the battery clip. Yeah, Chad's interesting. Chad has an entirely other discussion going on, which is fine. I'm going to give myself more to work with now. I think I cut things overly short with the last one. Swear by this little battery stripper. One of the things about this is if you strip a wire too far back, you can always nip the end off of it and make it tidier. If you don't strip it far enough back, it can be somewhat cumbersome to do that. So let's see, where's our VSS? VSS is literally the opposite corner. So this corner is power, this corner is going to be ground. And I could be running some of these wires underneath the circuit board, but for this I'm running them over the front of the circuit board. Just because why not? I'm going to see whether maybe I can do a special trick here. Possibly not. I was thinking if I can poke this into the same hole that the leg of the chip is in, but I don't think I can actually do that, so I'm not worried about it. However, I figured out a new way of bending the wire. Just poke it into a hole and fold it over. And having done that, that is definitely, oh God, I dropped it. Oh no, where'd you go? I can always make another if I'm going to have to make another. Okay, making another wire, I lost the first one. You know, it's actually even worse if you're doing surface mount components, because if you lose one of those, forget it. You drop it and it's just gone. People do solder surface mount components. Here I am soldering 22 gauge wires and losing them because I'm old and feeble. So let's see. Strip another wire on both sides. Drop the insulation on my arm. Get off you. And yes, this is going somewhere, I promise. Fold that over, poke it through. Fold this away and see whether I can make this connection. I don't know how well you can see all of this, but it's amazing to even be this far. Try to hold it steady. There we go. And that is a soldered to the pin of the chip connection. You'll also notice that these are fairly tidy, because otherwise they're going to sort of overlap, and if you have them touching each other, that's bad. Where's my nippers? Nipping off the stray area here. And once I fold this over and use the needle nose pliers to plug it into one of these holes, or rather fold it over and then just the pliers might actually be better. Doesn't want to go. I may have goozled myself a little bit in that nope, there it goes. As you can see, two wires now neatly plugged into these little pin sockets. This is what I've got in mind for wiring up these synths, because these are so cheap compared to regular jacks and cables and things. They are also tiny, as you can plainly see. So, VDD is pin 14. I'm going to grab one of these. I think this is positive or ground. So therefore it's not going to actually hurt this cap, but I think maybe the picofarad cap is going to be better because it's smaller. It'll make an audio frequency. So this is voltage plus. This is a positive. This is VSS. This is ground. So next to VSS is dash C, C, dash B, B, dash A, A. And when I say dash C or dash B, what the data sheet says is A channel, A input. So this one on the end, this is an input. G equals dash over an A. That's right next to it. That is an output. So right here on the very end is one of our oscillators waiting to happen. Now, how does that work? By shorting these pins together in a particular way. And I'm pretty sure the way we do that is by wiring a capacitor to ground. For now, I'm going to use the needle nose pliers and just try to poke this into my pin jack, which is not easy, but seems to have worked. This is a slightly, oh no, there it goes. This is a thinner wire, so it barely wants to connect, but I have made the connection to ground nevertheless. And that end is going to go to the input. So the other side of this capacitor It's going to go to A, which is directly across from the voltage plus. On this, like when I'm done, I'll have those pieces of paper with the big chip drawn on them and the things on the end, and you'll be able to look at that and be like, okay, here's top view, and this is what connects to this pin. Right now, I'm just going by a much more crude form of that, but all the same, this works. This is the same thing as end of the capacitor goes to ground, and then the other end of the capacitor goes to the input. The next thing to make happen is this. I got to take a trim pot, or indeed, I could take a slide pot, and that might be fun. And the way this thing works, if I set it up like this, the top two things here are going to be a variable resistance. And this particular trim pot will fit neatly into, I think this will fit neatly into the holes here. Or if I force it, let's force it. So part of this process is just getting stuff to fit on whatever you're building. I've successfully now done that. It's a little weird. I might want to drill out some of these holes in order to make it fit better, because one of the things that's happening is we're making this board flex. But it doesn't matter. It'll still work for now. And so the opposite side of this, one of these connections goes to where this input is. And I can do that by folding this the opposite direction. Maybe I'll move this closer. I am going to move this closer. So what I'm doing now is making a cheap and cheerful little connection here. I'll probably also skip trimming this until I've actually got it soldered on. And what you can see underneath here is the wire goes through the hole next to the pin, and then over here it scooches over and loops around the pin, which I'm going to solder on, and then continues over here to connect to this side of the slide pod. And let's solder that together right now while it's still in one piece. Once it's soldered together, it'll be a little bit more stable. Same thing will apply to any pot. That's good enough. See how fast that was? Stuff like this, you don't want to linger. You don't want to sit around with the soldering iron on a chip, just sitting there and heating it up and heating it up. That is extremely bad mojo. I'll nip off that piece of wire. And go and find another piece of wire from somewhere. One of the things about this 22 gauge stuff is that it's nice, but it's also really kind of heavy. I'm stripping a whole bunch of it off here. And I'm going to leave it connected. So now I have this and a whole bunch of stripped area. And I'm going to come up with a way of having this sit in place. maybe fold this pin up as well. You can't really see it, but trust me on this. And then maybe fold it down like this. I'm trying to make it where it'll sit stable long enough for me to solder it together. And that's probably not it, but you know what? Let's just loop it around. And fold the pin over it gently, eyeball it to see if it's shorting again. Scooch it down, fold this wire over again because it's making things fall over. Thus is the life of the DIY hacker, trying to get anything to hold together or behave. Now you can kind of see what I've got there. I'm definitely going to do as much of this as possible under the macro so that you can see exactly how it's all done bit by bit. This time I'm going to do this one first. Got it. And now, very light touch on the end, and I'm trying to touch the wire, not the pin. Got it. Now we can unwind this again. Nip off the wire. Moving all of my random paper over, it's falling on the floor. You wouldn't believe how much stuff I'm surrounded by right now. And here's where we start to see whether we made something happen. Now note that we've got these wires coming off of this, but they're also connected to these places on this pot. So if this works, I can touch the output of the cable to these, and even though I'm not running a ground wire, it should still make a noise if I have something. If not, we're probably going to call it a day, unless there's an easy way that I can fix it. Firstly, black goes to negative, red goes to positive. In theory, I should be able to plug this in and it won't explode, but we're going to find out right now. And that is a no explosion. But do we have something? That's more questionable. Okay, let's touch the ground. And it's looking like the answer is no, we got nothing. Let's touch it to some of these other pins and see whether the chip's alive or not. It should make a pop some of the time. Okay, let's touch it to V+. Maybe my battery's dead? Well, if my battery is dead, okay, that's the sound of a battery. Bigger pop. So the next part is, are we making a connection through the battery clip? So I do also have a multimeter. Might be worth starting to fool with that a little bit too. So I think that's the next thing, rather than purely audio-oriented debugging. Gonna dig up the multimeter, gonna see whether voltage is getting to the chip. There's a certain amount of this that I'm willing to do, and then we're gonna stop. I am still streaming without dropping any frames, but I can't tell whether anything is happening or whether anybody is still here. Don't care. Super unprepared. It's amazing that I've gotten as far as I have. On we go. Nobody's going to mistake me for a professional, which is good in some ways, because it's like then when you start making stuff happen and it gets really weird, that becomes more fun. So let's see. Here's a multimeter. That's what I'm going to be looking at. So first of all, let's get these pins exposed. By that I mean this ends of these. Once I've done that, I've got this under power. So I'm going to touch the things to the wires and see whether I get a voltage. Okay, so minus to plus seems to be 0.70 volts. That's not an impressive amount of volts. Is our battery 0.7 volts? That would be not an impressive amount of volts. Now our battery is 8 volts. Okay, so the next thing is this battery clip dead. Touching the battery clip to the multimeters. That's 8 volts. Let's plug you back in and see what we got, because we've got all these little connections in here. So the question is, are some of those wired up wrong or simply not making contact? So I can plug that in and this in, although they're not really an optimal wire for this purpose. This time let's touch the pins here to more of these jack sockets and see what that shows us, if anything. We got a 0.7 volts there as well. So here's the next thing I'm going to do. I'm going to unplug the ground that goes to the chip. Am I still getting 0.7 volts? Okay, if I unplug the ground, I'm getting 1.5 volts. So that's super weird, because the only thing that's really plugged in here is this capacitor, of which I have so many of. And it would be really a funny thing if all the capacitors were dead, and that's why they were on wholesale. But one way to find out, we're going to cut the leads of the capacitor. Because the chip will still work without the capacitor. This was meant to be as part of a power supply that would make up a distributed power supply that would be kind of larger and more effective, but if it is not actually functioning, but that's a question, is it not actually functioning? So back over to here, now we touch this. Now we have 8 volts. So we can now plug the ground back in. I'll double check. Do we still have 8 volts now that the chip is in the circuit? Now we have 0.69 volts now that the chip is in the circuit. That seems unusual. Okay, I'm going to guess this is a dead chip. So let's unplug the battery. Ignore that capacitor. I'm going to have to test those capacitors and see if they're alive or dead, because that's dismaying. The idea that I have large quantities of dead stuff is a bit of a waste of time, really kind of is. And we are going to desolder this chip and leave the rest of the circuit in place. How, you ask? Brute force. That bit let go. Or actually, I have an even better idea. Unplug the wire and release it. Unplug this wire and release it. Take a bit of doing, but that's fine. And lastly, we have these two connections. This one can go like this. This one can go like this. And we can yank this chip right out like this. And throw it away. I don't know what the deal is that that one looked kind of tarnished and then was dead. But we will see whether we can get any further. You know what? I'm going to kick off my slippers again in hopes of being more grounded, because that's one of the things that can kill these chips. So there's a possibility that that's what happened. Alrighty, back into the breach. Oh, you know something though? You know, I think I might have wired it up wrong. I'll tell you what I did wrong. You know how I said there's a dot? I was looking for the dot, but it's this detent that probably corresponds to the dot. So it's very possible I had that chip in upside down. It doesn't matter. It's almost worthless, so I don't care that I destroyed it. But what we're going to do is see whether we can make this work by going after this one more time. I'm trying to bend the legs so that they'll fit in here. Signs point to yes. These legs also look a little tarnished to me, but worst things happen in war, I don't care. Actually, the other ends look fine. So here we go. Let's lean this over so that I can try to connect to this pin. Yeah, it is very possible that I wired it up upside down. I got fooled by the fact that there is a dot on the chip, but it's actually, there's a notch in there, and I'm almost certain that that's what I would have been looking for. My glasses aren't doing a very good job of letting me see what these pins are doing. These are my reading glasses rather than my close-up glasses. But if I bend the pin this way and lean the wire this way and then give up and put on my close-up glasses, yet another thing sitting around here to fall over. My glasses can fall over now. See, these ones, better. I'm looking to get some more like that, but for now, This might just be the ticket, and I gotta stretch this wire over somehow so that I can make it connect. Screw it, I'll just force it over the other way. Any way that'll work. Any way that'll work is fair game. Same deal with that. Now that's two little wires. The close-up glasses, I can't look over them, so I can't see the screen at all now. So if you say anything in chat, I can't even tell whether we're focused. Again, work in progress. This is going to have to get much better. This is only the second week and the first time I was actually wiring anything. One connection. Two connections. Let's get that power supply in there, shall we? And this one over here goes to hot. Bend the wire just a little more. I'm pretty sure that got the pin. Yeah, that got the pin. I can also tell by if it's loose here or not. Although you can't wiggle this around too easily because the only thing really holding it is the pin on the other side. And I'm just going to bend this right now and insert it into the hole. That's a terrible job, but fine. And then the opposite corner is the ground. And I can see where it was connected. And I can see that it goes here. Kind of popping out though, but let's get this over. And that's a really kludgy job, but I believe it touched the ground wire. Again, with the needle nose pliers or the tweezers would work as well to make it be oriented correctly. Plugging that in. I don't know what the problem of that capacitor was, although the capacitor might actually be fine. It might have been the chip being wired up wrong. Our cable is still fine. Plugging in the ground and hot. Dragging over the wire. We have a result. These are very high frequencies because this is a 4,700 picofarad capacitor. But you know, we can do something about that. The capacitor goes to ground. Even without, don't even have to turn the bugger off. Ground is the opposite of what's on this tantalone capacitor, plus we'll go to the circuit. So if I tack this capacitor on, and let's do that by poking it through one of the holes just because. Let's do it like this. No, let's do it like this. Now we're going to solder that in place. Don't know whether you can see it. I can't see the screen anymore. That needs to be bent over more. Come on, you. Yeah, there we go. Holding it down with the soldering iron because brute force, and bead of solder holding it in place. And now since that goes to the hot, I think, actually that doesn't make a lot of sense, but no, it does. It does. Other end of the wire of the capacitor goes to, let's hope this doesn't explode. Probably wouldn't hurt me very badly if it did, because it's not huge. Other end of the capacitor plugging into ground. Come on, in you go. There it goes. Now, and if I had a spare piece of wire, one of the reasons this is having such a high frequency is because this is a 10 kilo ohms slide pot. This is a 200 kilo ohms rotary pot. The reason I have the slide pot here is because it's easier to move. And for that reason, one of the reasons of getting such a loud buzz is there's no ground connection here. I'm just touching a amp wire to part of the circuit as it goes. If there was a ground connection, I think it would be much louder, and we wouldn't also have this noisy hum. Now I'm low on ground connections because I only have 4 places to stick them, but one of the things about it is I do have this bit of the wire kicking around. So if I touch this to the ground, there we go. And square wave. And that's what you can get making circuits instead of plugins. Good luck making a plug-in square wave oscillator scream like that. So I'm going to call that a day. It's close to an hour longer than I intended to do. In future, we will have a little bit more preparation. Oh, no, I'm not plugging anything into mains just yet. We're battery powered for the moment. I had no idea I had captions on. That's something that I could look into in future. And yeah, we successfully made an oscillator that screams and makes square waves and things. So, given how hard this was to do, I would say not so bad. I think many of these videos are going to be like, yeah, skip to the end if you want to hear anything real happening. But that's fine. That's fine. And if you were wondering what it took to wire up a analog synthesizer or oscillator or something, well, you just saw me do that with virtually no parts and no care and attention to detail or anything of the sort. And you know, it kind of worked. So if we wanted to, and you know, I can grab the thing. And it's right here. It's a battery and a couple of different capacitors and a potentiometer and a chip. And I put the chip in backwards and it didn't matter. It just didn't work. I threw away a chip because I'd run voltage into it the wrong place. And yeah, we got a thing. We made also, one of these is square wave and one of these is triangle. And then if we touch all the other pins of the circuit, which might just cause it to explode, but we might be able to do some circuit bendy stuff. Yeah, it's a motorcycle. Yeah, it's 1:44 in the afternoon. And you may ask, why do I dare to just short out all the pins on the other side of this with my finger and potentially blow it up with static electricity? It's because this part cost about 25 cents. And I just killed one and put another one in the course of about a minute and a half. So I can do this all I want. That's just for your Atari Punk console. I've been thinking about ways of wiring these chip parts into each other in bizarre ways that would cause strange results. Here's one of them. And there you have it. So welcome to Airwindows DIY Stream as a thing. My hope is that as I continue to build these, I'll be building them into like little form factors like this that can go on a rack and that can be assembled with like patch wires like the ones I'm using here to actually do sensible things. But this is why I want to get into this and get people into this, it doesn't take much to get into some of the wild side of your little analog circuits. And some of those noises that I just made, in future I will have a DI input so that I can run it straight into the stream rather than into a amplifier in the back of the room. And I'm thinking it's going to make noises that you're not going to easily get out of plugins. But the neat thing about this is that when you can do this kind of stuff and you make your noises and they're really like gnarly analog noises, if you capture those into the computer and multi-track them and do stuff with them, you know, sequence them, put VCAs on them so that you can make them do stuff, then you can mix them in the computer and get a lot of mileage out of that. It's not so much mixing and filtering and combining that is that difficult to do in the computer. The stuff that's difficult to do in the computer is the gnarly, nonlinear, distorty stuff. And we just did some of that for under $1 in parts. And in the course of a less than 3-hour live stream, a solid hour of which was just me telling you about future projects and stuff. So in future, we're going to have a bit more of a head start on this kind of stuff. And we'll hopefully get more spectacular results. Like I might wire some of these things up and be like, okay, now we're going to plug them together. But it's also worth wiring stuff up on stream because I think you saw to some extent, like, this is how long you hold the soldering iron to those tiny, tiny little pins and touch the solder to it in order to make the connection. You'd see me just be like, boop, and then it's done. And that's important too, because the second time I tried, having put the chip in right side up instead of upside down, it worked perfectly. And part of that is I wasn't heating it up like a bomb, holding the soldering iron on it for half an hour, trying to figure out how to do it. You get that stuff sorted out and you start doing it properly. You know, go and get reading glasses or whatever if you need the close-up vision, which I obviously do. And then you can start playing with the thing. And the great thing about this stuff is that when you do it properly, you do it like this. If you break it, who cares? I'll solder this, take the stuff off, and pop another chip in there if it blows up. You know, I took the capacitor off and just cut the cables to the capacitor to such a point where basically it'd be ready to throw it away, in the belief that the problem was that the capacitor was not hooked up right. It was probably fine. I had the chip in upside down. But, you know, I destroyed or at least cut short a capacitor. Here's 600 more. I sincerely hope that they work and it wasn't a problem with that. But there's 600 more. So if they're fine, that's not a problem either. This was more along the lines of a 50-cent capacitor, but still, same deal. If I wired it up backwards, and since it's a tantalum, it popped and made a little purple smoke and died, I can get another one. All of this stuff is part of putting together your DIY type stuff. And when you do that, the kinds of things that you end up making can be stuff like this. The circuits in this guy, and this is like an $800 freaky drone synthesizer. The circuits inside one of these are not all that different from what I did here. Like the mod delay is, I think, a PT2399. So it's like one of those. The distortions, the chips and op amps and circuits. The oscillators, we can make oscillators. What makes this $800 box is the knobs and the wonderful heavy box and the fact that somebody thought this stuff up. and sculpted it into a synthesizer that is approachable and interesting and that you can do stuff with. But it shouldn't be intimidating doing this kind of thing, because it's just, you know, you got to start playing with it. You got to just start playing with it. I also hope to do some guitar stomp box type things. Anyway, I think that ably demonstrates what I'm up to as far as the DIY stream is concerned, and we'll go onwards from there. This was I knew this was going to be a really slow one because of my extreme unpreparedness. But yeah, you've just seen that I can get through to a result even if I do it wrong first time through. And as the very end, I made a bunch of really heinous noises, even though only one of these oscillators was even hooked up. A lot of those noises were made by sort of shorting out with my finger other oscillators that weren't even hooked up. They're just loose, and I'm wiring them all into each other by touching my finger to them, which has resistance and is therefore connecting everything to everything else. And that's part of the secret. So, I think that is a day's work, and we'll be doing more. And the more I accumulate, again, like I said, since I'm over $2,000 in the Patreon, anything beyond $2,000 gets added up and put into collections of parts that I will mail to people. You'll probably have to get your own soldering iron. You'll probably have to get your own stuff, because I don't think I can send solder in the mail either. But I can send some of these little parts off to people just to get you started. And I'm looking forward to doing that. I'll talk to you folks later. Bye-bye.